In our previous video, we had discussed about fault model in DFT and its types. Functional and current fault model I had explained in detail. There are two topics we need to understand before moving to speed fault model. First is test vectors and second is working of a scan chain. In today's video, we'll discuss about test patterns or sometimes called test vectors. Welcome to DFT Decoded, where we demystify the fascinating world of design for test. Hello folks, this is Ankit and I'm passionate about bridging the gap between technology and understanding. With a background in DFT, I created this channel to help engineers, students and tech enthusiasts to navigate the intricate world of DFT. I'll try to explain DFT, which is a crucial part of chip design, in a most simplified way. I'll cover all theoretical and technical concepts, as well as we'll discuss a lot of problems and issues we faced at DFT as an engineer and try to explain the solution in a most simplified way. So let's begin with question: what are test patterns? Now, one thing I want to clear in this video, we will take simple example of AND gate or gate, so that we can understand topic more clearly. In actual scenario, test patterns are generated to detect faults on much more complex design, but that will be a bit hard to explain here. Test patterns are a sequence of binary values that are used to detect any faults on circuit. Example 10110110 and so on. Now there are some basic notes which I want to explain here before moving further. For AND gate, if any pin is 0, its output will be 0, right? 0 is the output deciding value and 1 is not an output deciding value for an AND gate. Suppose if I make A as 0, then for sure Y will be 0 irrespective of value of B, and if we make B as 0, then Y will be 0 irrespective of value of A. For AND gate, if one pin is 1, then output will depend upon other value of pin. Suppose if we make A as 1, then our output Y will depend upon value of B. If B will be 0, then output will be 0, and if B will be 1, then output will also be 1. I hope these basics are clear to you. Similarly, for OR gate, if any pin is 1, then its output will be 1. 1 is the output deciding value and 0 is not an output deciding value for an OR gate. If I make A as 1, then without taking care of value of B, we can say Y will be 1. And if we make B as 1, then without seeing value of B, we can say that output of this OR gate will be 1. For OR gate, if one pin is 0, then output will depend upon other pin value. Suppose we make B as 0, then output Y will depend upon value of A. If we make A as 0, then Y will be 0, and if we make A as 1, then Y will also be 1. I hope this is clear. How to generate test patterns to detect faults? Let's generate test patterns to detect fault on OR gate. In this example, we want to detect fault on input A for an OR gate. For a fault-free OR gate, below is the truth table. If value A is 0 and value B is 0, then Y will be 0, and for rest of the combinations, the output Y will be 1. During pattern generation, to detect fault on any input pin, here pin A, other input pin like B of that logic gate should act as a non-output deciding value. We have discussed in earlier slide that for an OR gate, its non-output deciding value is 0, right? So, initializing second input pin as non-output deciding value. So, we are deciding B as 0. For a fault-free input pin A of OR gate, Y will be 0 when A will be 0 and Y will be 1 when A will be 1. B, we are already making it as 0 because it's a non-output deciding value. So here we have a pattern set for a fault-free input pin A of OR gate. We have AB as 0, 0 and output as 0, and when A is 1 and B is 0, output is 1. Here in this pattern set, we have only combinations of 0, 0, 1, 0, and we don't have 0, 1 and 1, 1, because if we want to detect fault on pin A, then pin P should be non-output deciding value, and non-output deciding value will either be 0 or 1. It won't change its value. So here we have just two sets like 0, 0 and 1, 0. Suppose A pin has stuck at 0 fault. Let's again generate pattern. Initialize B to non-output deciding value like 0. And we can see in figure that A is stuck at 0 fault. Irrespective of value of A, C will give 0 as output. If we make A as 0, then also Y will be 0, and if we make A as 1, then also Y will be 0, because our A pin is stuck at 0 fault. So this is the pattern for a faulty input pin A of OR gate. If we give A as 0 and B as 0, then Y will be 0, but if we give A as 1 and B as 0, then also output Y will be 0. So this is a wrong value, right? This is the overall summary of the pattern we have generated for a faulty input pin A of an OR gate. Suppose now here this first set of patterns is when your A pin is not stuck at 0 fault. So when A is 0 and B is 0, your output is 0, and when A is 1 and B is 0, then output is 1. So this is the output for a fault-free A pin. Here one thing to notice, we are making B as non-output deciding value, which is 0. And the second set of this pattern is when your A pin is stuck at 0. When A is 0 and B is 0, then output is 0. But when A is 1 and B is 0, then also our output Y is 0. So this pattern output set is when if A pin is stuck at 0. So overall we have a pattern set which can help us to tell whether our input pin of an OR gate is stuck at 0 or it is not stuck at 0 fault. I hope this is clear. Let's generate test patterns to detect fault on AND gate. Here in this figure, assuming A pin is having stuck at 1 fault, and we have to generate test vectors that can detect this fault. initializing B pin to 1 as it is not an output deciding value for AND gate. For a fault-free input pin A, output is depending upon value of A pin. Output Y will be 0 when A will be 0 and output Y will be 1 when A will be 1. Perfect. Let's move further. Pattern when input A is stuck at 1. Now, if we give input A as 1, then output will be 1. But even if we give A to 0, then also its output will be 1 because our A pin is stuck at 1 fault. Here we have overall set of test vectors for a fault-free input A pin and for a faulty input A pin. The first set, this one, is when your A pin is not having an stuck at 1 fault. If we give A as 1 and B as 1, then we can see output is coming as 1. And if we give A 0 and B as 1, then we are seeing output as coming 0. So this is the normal working of AND gate without having any fault on it. But the second set is the pattern which is telling that our A pin is stuck at 1. If we give A as 1 and B as 1, then output will be 1. But if we give B as 1 and A as 0, then also our output is coming as 1 because our A pin is stuck at 1 fault. So overall, this complete pattern set can help us to tell whether for an AND gate A pin is having stuck at 1 fault or it don't have stuck at 1 fault. There is a task for you. Can you generate test pattern to detect stuck at 1 fault on output of an AND gate? Give a try on this. So that's the end of video on test patterns. I hope you find this helpful. Please give your feedback and valuable suggestions. Thank you. Thank you.